Good afternoon, everyone. Good day. Anyways, I am Lubu Marjolincy, and today we are about to answer our midterm examination in BS Ed Math 7 Differential Calculus. So let's choose the correct answer and explain why we choose this answer among the given items. So for item number 1, we have here a teacher defines f of x is equal to 1 over x minus 3 and asks students to identify restrictions before graphing. Which response shows correct reasoning? So for this item, as you can see, the denominator cannot be 0 because when we divide something by 0, it is undefined. So setting the denominator equal to given gives x plus 3 is equal to 0. So, our answer for this item is basically letter D. With the domain must exclude x is equal to negative 3. So, basically, negative 3 must be excluded. Therefore, the correct answer for this reasoning is that the domain excludes x is equal to negative 3. Okay? Because when you negative 3 minus 3 is basically 0. So let's exclude the negative 3. For the next item, number 2, a student claims that the domain of f of x is equal to the square root of x minus 5 is all real numbers. Now, what misconception is present? Now, for square root, the expression inside must be greater than or equal to 0. That means x minus 5 greater than or equal to 0. So x greater than or equal to 5 is not all real numbers. The student made mistake of ignoring the restriction that radicands cannot be negative. Always remember, guys, that when you have square root, the number inside must not be negative. So our answer for this item is letter B, ignoring negative radicand restrictions. Okay, so for number 3, again, for number 1 is letter D, number 2 is letter B. For number 3, a function models the height of projectile hd is equal to negative t squared plus 6t. What is the most appropriate domain in text? So, in this item, guys, time cannot be negative, so t is greater than or equal to 0. Also, the projectile lands when height becomes 0 again, which happens as t is equal to 6. Therefore, the realistic domain is from launch to landing. So, our answer for this item is letter C. 0 must be t must be less than or equal to 0, or t must be greater than or equal to 0, or t must be less than or equal to 6. So our answer for this item number 3 is basically letter C. For number 4, a student sketches y is equal to the square root of x minus x squared. Now, which description of its range is correct? So, this represents the upper half of a circle with radius 2. Now, the square root makes values of y non-negative. So, the smallest value is 0 and the largest is 2. Therefore, the correct range for this item is y must be greater than or equal to 0, or y must be less than or equal to 0, and y must be greater than or equal to 2. So basically, our answer for this item is letter C. Negative 2. Yes. So our answer for this item is basically letter D. Sorry. So for our item number 5, which situation best explains why domain must be restricted? So domains are restricted when operations can become identified, or when you divide something when you divide something to 0, that means the denominator can be undefined. So, square roots require non-negative values and denominators cannot be 0. Now, these two situations frequently limit possible x values. Therefore, restrictions happen when working with square roots or denominators. So, our answer for this item is letter B. Restriction happen when dealing with square roots or denominators. For item number 6, a function is defined as f of x is equal to the square root of x minus 2 over x minus 4. What is the domain? So the square root requires x minus 2 greater than or equal to 0. So x must be greater than or equal to 0. Now the denominator cannot be 0, so x must not equal to 4. Now combining both gives the answer of x must be greater than or equal to 2 and x will not be equal to 0. So our answer for this item is basically letter C. Next item, number 7. A teacher asks students to determine the range of y is equal to x squared. Now one student says all real numbers. What is the correct feedback? So squaring and real numbers always produce a non-negative result. That means outputs are always y must be greater than or equal to 0. Therefore, the student's statement that the range is all non-negative numbers is basically correct. So our answer for this item is letter A, correct. Number 8. Which function has restricted domain due to logarithmic properties? So, logarithmic function require the input to be positive. Always remember that one. The input must be positive, which creates domain restrictions. However, polynomial functions like y is equal to x squared are defined for all real numbers. Therefore, the function with restricted domain due to logarithm properties is the logarithmic one. So, our answer for this item is equal to y is equal to x squared. Okay, for item number 9, a student evaluates x squared minus 4 over x minus 2 and gets 0. What is the error? So, when we substitute x is equal to 2, makes the denominator equal to 0. So, division by 0 is undefined. So, the expression cannot equal 0 at that point. Therefore, comes from attempting to evaluate where the denominator equals to 0. So our answer for this item is letter B. Denominator is 0. For this, for item number 9, a student evaluates x minus 2 is x squared minus 4 over x minus 2 and gets 0. What is the correct error? So the correct error is the denominator is 0. For item number 10, a teacher uses a table of values approaching x is equal to 1. What concept is emphasized? So, using tables of values near x help observe how function behave as it approaches a number. Now, this method estimates the value the function gets closer to without direct substitution. Therefore, making tables supports a numerical approach to limits. So basically, our answer to this item is letter C, numerical approach to limits. Okay, so for number 11, evaluate sin x over x. So when evaluating the limit of x and x approaches 0, we simply substitute the value because the function is continuous. So the value of x gets closer and closer to 0 as we approach to that point. Therefore, the limit is equal to 0. Our answer for number 11 is letter A. As to proceed, we have here item number 12. A function approaches different values from left and right. What conclusion is correct? So for a limit to exist, the left-hand limit and the right-hand limit must be equal. Now, if they approach different values, then the function does not settle to one another because the values differ and the limit does not exist. So basically, our answer for this item is letter B. The limit, letter C, the limit does not exist. Number 13. A student simplifies before taking limit. Why is this important? Now, many limits results in expressions like 0 over 0, and it is called indeterminate forms. Now, simplifying the expression first often removes the factor causing the problem. Now, these allow proper evaluation of the limit without undefined expression. So, basically, our answer for this item is this avoids indeterminate forms. So, the correct answer is letter C. For number 14, a teacher introduces derivatives as rate of change. Which interpretation is most accurate? Okay. So, wait. A derivative represents how fast a function changes at a point. Now, graphically, this is shown by the slope of a tangent line touching the curve at that point. Now, therefore, the most accurate interpretation of derivative as rate of change is the slope of a tangent line. So, our answer for number 14 is letter B. 15. A function represents velocity. What does its derivative represent? So, when we have velocity, its derivative is basically acceleration. As to proceed, we have here number 16. The chain rule expresses what? Basically, the chain rule expresses derivative of composition because the chain rule is used when one function is placed inside another function. Now, it tells us how to differentiate composite function. Therefore, it represents the derivative of composition. So, basically, the chain rule expresses the derivative of a composition. For item number 17, we have here a function is undefined at a point but limit exists. What type of discontinuity is this? So, if the function is undefined but the limit exists, there is usually a hole in the graph. A hole. So, this type of break can be fixed by redefining the function value. Therefore, it is called removable discontinuity. For item number 18, a student evaluates f of x using values less than 4. Why is this approach correct? So, using the value smaller than 4 means approaching 4 from the left side. Now, this helps determine the left-hand limit. Therefore, this method determines behavior from the left. So, our answer for this item is basically letter B. It determines behavior from the left. For item number 19, we have here, a function is defined as f of x is equal to 2x plus 1, x less than 15 minus xx greater than or equal to 1. What is f of x? So, for item number 19, let's solve this like this. Let's have this one. For this item, we have here 2x plus 1 is equal to 0. 0. Now, when we have 2x, so our 2x now is equal to negative 1. X is equal to 1 half. 1 half. So, the second factor is 5 minus x. 5 minus x is equal, So, our x now is 1 half. Let's erase this x. And the second factor is 5x. 5 minus x is equal to 0. And x is equal to negative 5. So, let's go back to this item. Number 19. So, among the given choices, 4 appears correct based on choices. But mathematically, solutions are negative 1/2 and 5. Okay. Negative 1/2 and 5. So, the answer corresponds to available correct option. So, our answer for this item is basically 4. So, our answer is letter D. Okay, for number 20. A student evaluates 1 over x minus 2 using table of values and observe that the function increases without bound from one side and decreases without bound from another. What is the most accurate solution? So, when values go to positive infinity from one side and negative infinity from the other, the function behaves differently on each side. So this means the limit does not exist because sides diverge. Therefore, one-side limits diverge to opposite infinites. So our answer for this item is basically letter B. The two-sided limit does not exist because one-side limits diverge to the opposite infinities. For item number 21, a graph shows a vertical asymptote at x is equal to negative 1. What does this imply? So a vertical asymptote means the function grows very large or very small next near that x value. So as x approaches to negative 1, the function values move toward positive or negative infinity. Therefore, the correct interpretation is that the function approaches to infinity. So our answer for this item is basically letter C. Okay, let's have number 22. A student asks why dividing numerator and denominator by x is useful. What is the best reason? So, dividing numerator and denominator by the highest power of x helps determine limit as x becomes very large. Now, this simplifies the expression and reveals horizontal asymptotes. Therefore, it helps simplifying behavior at infinity. So, our answer for this item is basically letter D. Simplifies behavior at infinity. So, for number 23, which function has horizontal asymptote y is equal to 2? So, my answer for this is letter A, 2x over 2. Why? Because to find the horizontal asymptotes, we need to compare the degrees of numerator and denominator. Now, if they are equal, the horizontal asymptotes equals to the ratio of leading coefficient. So, in this item, we have here 2x over x, and the ratio is 2 over 1. So, the horizontal asymptotes is y is equal to 2. So, our answer for this item is basically letter A, 2x over x. Let's not complicate it, guys. For number 24, a function is continuous at x is equal to A, if what? So, continuity requires 3 conditions. If the function exists, if the limit exists, and both are equal. Now, the most important condition is that the limit equals the function values. Therefore, continuity occurs when the limit equals to the function value. So, basically, our answer for this item is letter C, when the limit equals function value. That's for number 24. Let's proceed to item number 25. Okay, item number 25. Function has a whole at x is equal to 2. What type of discontinuity is this? So basically, this type of discontinuity is jump, because a whole usually means removable discontinuity. But among the choices shown, the closest match was selected. A removable discontinuity occurs when the function value is missing, but the limit exists. Therefore, it represents a removable type discontinuity, which is a whole. So, our answer for this item is basically letter A, jump. 26. A function has different left and right limits. What type? So, when we have a function that is different left and right limits, it is basically jump. Because a jump discontinuity happens when the left hand and right hand limit exist but are not equal. So this creates a sudden change in function value. Therefore, different left and right limits indicates jump discontinuity. So our answer for the item number 26 is basically letter B. For 27, which function is continuous everywhere? So our answer for this item, continuous everywhere. Polynomial functions are continuous for real numbers. Always remember that when we have polynomial, it is continuous everywhere. So they do not contain denominators, radicals, or logarithm that cause restrictions. Therefore, x squared is continuous everywhere. So our answer for this item is basically letter C, x squared. Number 28. A teacher asks why continuity matters in real-world models. What is the best response? So, for me, the answer for this item is basically letter B, ensures no sudden jumps. Because continuity means the function changes smoothly without sudden breaks. In real world, models like motion or temperature, sudden jumps may not make sense. Therefore, continuity ensures smooth transition without jumps. So our answer for that item is letter B. For 29, which scenario best represents a jump discontinuity? So in this item, the answer is sudden change in value. Because a jump discontinuity looks like a sudden break in the graph. The function moves from one value to another instantly. Therefore, a sudden change in value represents a jump discontinuity. For item number 30, a teacher uses piecewise function to illustrate continuity. Why effective? Because it demonstrates behavior at boundaries. When we say piecewise function, it shows how function behave at specific intervals. They help students observe what happens where pieces meet. Therefore, they are effective because they demonstrate behavior at boundaries. For item number 31, a student says the derivative is just a formula. What should teacher emphasizes? So, the teacher emphasizes graph interpretation. Because a derivative is not only a formula but also represents the slope of a tangent line. So, a tangent line on a graph. So, understanding its graphical meaning helps students visualize how function change. So, yeah, the answer for this item is graph interpretation. For number 32, a function is f of x is equal to x squared over x plus 1. Why not simplify before differentiating? So, why we can't simplify this before differentiating? We cannot simplify this algebraically. So, our answer for this number 32 is letter B. Because the numerator and denominator do not share common factor. So, the expression cannot be simplified. Because no cancellation is possible, the quotient rule must be used directly. Therefore, simplification is not possible before differentiating. So, the answer for this item is cannot simplify algebraically. For number 33, a function models position. Its derivative represents velocity because position measures location over time, and the derivative of position shows how fast position changes. Now, that rate is called velocity. So, our answer for this item is letter B. 34. A student gets correct derivative but incorrect simplification. What skill is lacking? Basically, the lacking skill that the student has is algebraic manipulation. Because if the derivative formula is correct but the final form is wrong, the issue lies in simplifying expressions. So, algebraic manipulation skills include combining terms and simplifying fractions. Therefore, the missing skill is algebraic manipulation. So, our answer for number 34 is letter D. For number 35, for y is equal to x sine x, the derivative of y is equal to what? So let's try to solve this using this one. What is y? So the equation is y is equal to x sine x. So let's use the product rule. The product rule states that the derivative of x, y plus x, y derivative. So let's use that formula. We have y here, y derivative is equal to the derivative of x. This is our first value and second value. So the derivative of x is 1. And let's just copy the sine x. Add 2 plus. That's plus, guys. Let's copy the x. And the derivative of sine x, basically cos x. Cos x. So, the derivative is y is equal to sine x. Sine x plus x cos x. X cos x. Or our answer is x. Sorry. So our answer is x cos x plus sine x. Okay, so our answer is x cos x plus sine x. Let's find this if naaba siya sa item. Okay, so our answer for number 35 is letter D. Let's just use the product rule in this item. Okay, for number 36, if y is equal to 5x over x3 minus 4, then the derivative of this one is, again, in this item, we just need to use the what? The quotient rule. So let's try to solve this using the quotient rule. Let's erase this first. Okay. So the given is 5x. Oh, wait. 5x over x minus 4. And the derivative of this is, that's our u is equal to 5x and our y is, our u is 5x and our v is x minus 4. So quotient rule is the derivative of u times v minus u times the derivative of v over v squared. So let's use that formula. So our y derivative here is equal to 5, which is our u. The derivative of 5x is 5 because 5 times 1, our x here is constant. No, our x is equal to 1. So 5 times 1 is 5. And let's multiply this by x minus 4 minus the 5x. And the derivative of x minus 4 is basically 1. Because 4 is constant and it is equal to 0. So, x minus 4 squared. So, that is the formula. Now, we will answer this one. 5x, let's distribute 5 to, let's distribute 5, distribute 5 to the quantity inside. So 5x minus 20, okay, minus 5x over copy x minus 4, oh, basta x minus 4 squared. Okay, so that is, sorry. So our final answer for this item is equal to 5x minus 20. So let's cancel this one and cancel this one. So our answer is negative 20 over x minus 4 squared. So let's find if naaba siya sa ato ang item or choices. For number 36. 5x or negative 20 over, wala siya sa choices. Okay, so let's just communicate to mom with this item. Number 36. So, actually, yeah, that is our answer for number 36. Negative 20 over x squared, x minus 4 squared. 37. Find the derivative of 5x squared times x plus 40 plus 47. So, in this item, we just need to what? Answer this one. We just need to answer this one. So, we have here 5x squared. So, the derivative of 5x squared. First, we just need to expand this item. So, we have here, in expanding this item, we come up with the answer 5x cubed plus 235x squared. Because 5 times 47 is 235. And let's, after expanding this, we can now differentiate this. So, the derivative of 5x cubed plus 235x2 is equal to 15x squared plus 470x. So, basically, our answer for this item is letter D. 38. The derivative of the function y is equal to 1 over 2 sine 2x is what? So, basically, in this item, we just need to use the chain. We just need to rewrite and use the chain rule. So, in rewriting this and using the chain rule, our final answer is negative cos 2x over 2 sine squared 2x. So basically, the answer is not here again. So that is the answer. The first thing that we need to do is to rewrite, use the chain rule, find the derivative of these items, and the final form gives negative cos 2x over 2 sine squared 2x. So for item number 40, that's 38. For item number 39, the final answer is 2 sine 1 over x minus 2x minus 2x cos 1 over x. So our answer for this item is letter B. Number 40. The derivative of y is equal to 2x minus 1 over x. So our answer for this item is basically letter B. For 41, let's make it faster because our minutes is already 38 minutes. 41. If g of 0 is equal to tan squared 50, then the derivative of g0 is basically, so let's differentiate each term separately using the power rule. So the derivative of x cubed is 3x squared. And the derivative of negative 5x plus negative 5x squared is negative 10x. So the derivative of 4x is 4, and the derivative of constant negative 7 is 0. No. Our answer for this item is letter B. 2 tan 50 sec 250. Okay? Yeah. So for item number 42, we have here yeah. So for item number 43, my answer in this item is basically A. For 44, the derivative find, let f of x is equal to this, and let's find is equal to 2. Oh, my answer in this item is like letter B. 45. For the function f of x graph is given below, choose the correct statement. So, in this item, f of x is right continuous at x is equal to 3. So, the answer is letter C. 46. The graph of the function is f is shown below, which the function statements about f is true. So, the derivative, the correct answer is letter C. For 47, for x minus 4, wait for a while. Okay, so for item number 47, we have here for x is not equal to 4, the function hx is equal to x squared plus x minus 20 over x minus 4. What value should be assigned to h4 to make hx continuous at h equal to 4? So first, we just need to factor the numerator. So in factoring the numerator, we come up with x squared plus x minus 20 is equal to x plus 5, x minus 4. So, we have here x plus 5, x minus 4 over x minus 4. After, we need to cancel x minus 4. That's why we have here x plus 5. Now, let's substitute the 4. So, 4 plus 5 is basically 9. So, but based on the choices, the intended factorization likewise was h4 is equal to 5. So, our answer for this item is letter C, number 5. So, for item number 48, we have here the graph of y is equal to x squared minus 9 over 3x minus 9. Hence, the answer for this is a removable discontinuity at x is equal to 3. Because in solving this one, first one, we just need to factor, and by factoring, we come up with the answer x squared minus 9 plus x minus 3, x plus 3. So, our x is equal to 3. So, when common factor cancels, the graph as a whole, not a symptom, this type of discontinuity is called removable discontinuity. Therefore, the correct answer is letter T, a removable discontinuity at x equals 3. For item number 49, what is the derivative of y is equal to x over square root of x, square root of 1 minus x squared? So, let's try to solve this item in our notes. Okay. Let's try to find the derivative of it. We need to erase this first. Let's erase this. So we have here y is equal to x over square root of 1 minus x squared. That's squared. Okay, so in finding the derivative of this one, we have here y, a joke. The derivative of this one is y prime, y prime is equal to x, which is 1. What happened? What happened to this, Bella? We have 1 multiplied by the derivative of this one. Okay, let's copy the 1 minus x squared. Let's copy the denominator, but not with its radicand. What happened, Bella? So the denominator is negative 1 over 2. Okay, it's not that easy, guys. 1 over 2 plus, that's they call this one, plus x minus 1/2. Negative 1/2. Oh, let's just continue here. 1/2, let's multiply this by 1, the denominator, negative 3 squared, and the derivative of the inside, which is negative 2x. Okay, so now the final we have here. Okay, so that is the, wait, sorry, it's not that easy pala. So in there we come up with 1 minus x squared, negative 1/2 plus x squared, 1 minus x squared, and the square of this is negative 3, 2. Negative 3. Okay, so the rule in the derivative is we don't, dapat wala tayong negative na exponent. So we need to bring down this item. Okay, we need to bring down the item so that wala tayong ma-negative. So our final answer is 1 minus 2x squared over, ma'am, asa man gikan ng 1 minus 2x squared? Here, and this, because sila raman ang dili negative. And 1 minus, no, this is negative. Sorry, joke. Kato nagikan sa itong equation kanina, guys. Sila itong gikopy mo, nagibutan na to siya sa numerator. And ato ang denominator is 1 minus x squared. Dire, kani. 1 minus x squared, 3, 2. Para dili na siya ma-negative. So, this is our final answer. That is the derivative of y is equal to x over square root of 1 minus x squared. So, let's proceed. So, the function is a product to expression. So, the product rule, kinahanglan ta mo gamit sa product rule. Okay? Product rule. Okay. So, the answer for the item is wala job. Wala. Larry says letter A, of course. And lastly, our number 50, determine the points of discontinuity of f of x is equal to 3x plus 2x over x minus 4. So, discontinuity occurs when the denominator becomes 0 because division by 0 is undefined, as we all know. So, each fraction creates its own restriction. Therefore, we need to find the value of x in this item. So, x over 3, our x here is equal to 0. And for our 2x over x minus 4, our x is equal to 4. So, our answer here is basically letter C. X is equal to 0 and 4. So, that is the answer of our midterm examination. That is everything. Okay. So, once again, I am Lubu Margilinsi and I hope that you learned something from this video. Thank you and God bless. Bye-bye.